So the next issue what you have is mixer linearity. So as we said in the receiver, the mixers are used. In the transmitter also we use mixers, and these mixers have to be highly linear. So with this expression we have seen what is the reason for third order non-linearity. So when you have a dependence on x cube of t, see here alpha 1 x plus alpha 3 x cube. Alpha 1 x is your required signal, but alpha 3 x is the third order non-linearity. So third order non-linearity, it will have a large impact on your circuit. The second term will represent the, see here, the when you substitute here and simplify, you get this expression. And when you simplify, you see here, second term will represent your GMSK signal with a threefold modulation index where occupying a larger bandwidth. You can see alpha 3 a cube by 4 cos omega ct minus 3 phi. So it is going to be a broader signal, and simulations indicate that even if non-linearity is less than 1%, the situation the effect is going to be negligible. So less than 1% non-linearity is accepted, but if it is going to be larger, then it is going to seriously affect your circuit. So the in most cases, when the input signal swing is large, the power amplifier starts going into saturation. See, for the signal A now, it will work if it is A, but see A cube now, the range will increase. So the power amplifier has to amplify the value to an even more larger value. So in such case, the power amplifier will go towards saturation. When saturation happens, the output power starts reducing. So that is when the even the power amplifier starts behaving in a non-linear fashion. So transmitter linearity is a very important thing which is required for the transmitters to ensure that the signal is free from distortion. As you see here, till a particular point, V out is proportional to V in. But after a particular input voltage, the output saturates. It has to go straight, but it saturates. So the beyond this 1 dB compression point, it is not advisable to use your power amplifiers because it will start introducing all types of distortions and non-linearities. It is determined how close it can come to 1 dB compression point while the degradation is negligible. So till 1 dB compression, the degradation is negligible, and once it crosses 1 dB compression point, then it goes to a state of non-linearity where the signal degradation is going to be very huge. So normal is okay, but if you are going to go for a 64 QAM, where you are going to have 64 points in your constellation, then you need to operate at 8 dB back off. 8 dB back off means if the if the 8 dB back off means if the peak swing of V naught produce occurs at 1 dB compression point, the average swing must not exceed V naught by 2.51. What they say is when you go beyond this compression point, the output power starts reducing by 8 dB. So this curve will increase and it will start coming down. So you can see when you increase V in, the output starts reducing. So the how much it is reducing, that is going to be called as back off. So you can see the circuit must operate at minimum 8 dB back off. Okay, so that will place a restriction on the or swing voltage swing on your receiver and as well as the power amp.